Alright, in this lecture we're going to learn about rational expressions. And before we tackle rational expressions, we got to do some groundwork. We got to remember some old rules that keep coming back to haunt us. Like if we have the same thing divided by the same thing, we have 1. And another thing we have to remember is order of operations, which we've been shorthanding as PEMDAS, where parentheses must be done first, then exponents, multiplication and division at the same time from left to right, and then addition and subtraction from to right. So, let's quickly remember simplifying an expression that is pretty nice. And it is a rational expression. It's just going to be a rational expression that has all numbers. So, let's say I have 3 all over 3 plus 5. Now, when you look at this, this is 3 divided by 3 plus 5. And there is implied parentheses around that 3 plus 5, which must be done first in the order of operations. So we have to satisfy that first. So we'll have 3 all over 3 plus 5 is 8, and we can't reduce the fraction anymore. There's never been an instance in which you said, oh, there's a 3 up top and a 3 on the bottom, so we can cancel them out. The reasoning why is because of order of operations. So you cannot cancel because there's implied parentheses. So be careful. On the other hand, if you had something like this, 3 over 15, in which, and I'm going to write 15 funky, so bear with me. If we had seen it like this, 3 over 3 times 5, because 15 is really 3 times 5. Because there's multiplication here and division that's occurring, we can actually kind of cheat and go ahead and say, well, 3 goes into itself once, 3 goes into itself once, and now we have 1/5. Very different from when we had the operation addition. And that's purely because here, when we have parentheses around 15, it's just saying this is a monomial, and it's being broken up into multiplication. And if you recall from order of operations, multiplication and division occur at the same time. Of course, they're from left to right, so there's a little bit of wiggle room we have, but that's what's allowing us to cancel. So be very careful. Addition and subtraction is the last thing in order of operations, so it's something we got to be wary of. Let's now try our first rational expression with this in mind. We have simplify 3x plus 2 all over 15x squared plus 16x plus 4. So, there is the first thing we have to do is make sure we understand there's implied parentheses. So, we have the numerator divided by the denominator. Do not get carried away and say, oh, there's an x up top. Can't talk. There's an x up top and an x in the bottom, and that allows them to cancel. Nothing allows that to happen, just by what we previously explained. If it still doesn't make too much sense and I went too fast, just rewatch it, think about it, remember order of operations. There's implied parentheses and they must be done first. But if I can get these things to be written as products, just like our previous problem where I rewrote 15 as 3 times 5, then I can actually cancel because I end up in multiplication and division, which occurs at the same time, of course, from left to right, but it gives me more wiggle room. And that's purely because multiplication is commutative, in which we can multiply 2 things together and switch the order and all is well. That's the beauty of it. So, if I can write this as a product, then I can cancel things out using that rule, x divided by x equals 1. So that's my goal. In order to write these things as a product, I must factor, which means to write as a product. So let's start with our numerator. We have 3x plus 2. It's in descending order. There's no GCF. There's only 2, well, the GCF is 1. I shouldn't say no GCF. The GCF is 1, so that makes it boring. And there's no way we can factor this binomial because it's not a difference of squares. So we leave it alone. So we have 3x plus 2, and I'm going to keep it in parentheses. That way I remind myself, hey, this is one whole thing. There's implied parentheses. I would have to add these two things together before any canceling. Now, let's take a look at the denominator. And I picked an ugly denominator just so we could get some extra practice. So, since the denominator, maybe I could factor it. There's no GCF other than 1, so I'm going to have to suffer with a trinomial where the leading coefficient is something other than 1. That means I got to use the AC method. So, let me label this as the denominator, and let me detour away from this page. Let me only worry about that denominator, which was 15x squared plus 16x plus 4. And let me double check and make sure I got that right. Yep. Okay. So, because we have a being something other than 1, we're going to use AC method, where we take 15 and we multiply it by 4. Now, 5 times 4 is 20. Carry the 2. 4 times 1 is 4, plus the 2 is 60. And it's all positive because the the A term's positive and the C term's positive. Now we find factors of 60 whose sum is going to get us positive 16. And you're probably already jumping out 6 and 10. Both are positive because the B term is positive, the bigger factor is positive. They multiply together to get a positive. All is positive. So now let me rewrite my expression where I break apart this middle term into the two factors. And now I factor by grouping. So we'll group the first two together. The GCF between them is 3x. Left behind is a 5x plus 2. We'll group together the second two. The GCF is 2. Left behind is a 5x plus 2. And that new GCF emerged between the two. That 5x plus 2 is the same. So we're going to go ahead and factor that out. And left behind is the goop in the front. So we have 3x plus 2. Now you probably already forgot the problem we originally were doing. This was just the denominator, and we were just getting some good practice in with AC method. So let me go back where I'm going to, instead of writing this ugly denominator that's not factored, write the factored denominator we came up with. We had 5x plus 2 times 3x plus 2. Now that this is multiplication and division, we can manipulate it. We have the same thing in the numerator that's in the denominator. So we can cancel them using this rule up here. They're going to each other once, and we are left with 1 over 5x plus 2. And that's our final answer. So this is how we're going to simplify. We're going to factor as much as possible. Make sure you factor completely and find any GCFs if able to. And then you can reduce by canceling the same thing over the same thing. Just be wary. You cannot cancel when it's addition, because addition's the last thing in the order of operations. So be very careful. And that's all for now.